All right, gang, we're still on the topic of array lists, but we're going to kind of veer off and also mention the concept of stacks. In other words, we're going to do something silly and implement a stack using an array list. Mostly just for the practice an array list, but it'll also burn in the concept of stacks into your brain. So here's what we're going to do. We're going to make a class called our stack. And our stack is going to have a array list in it so that we can insert things into it according to stack principles. So we could make another class that the stack is going to use, to insert, cars or, animals or whatever we wanted to put in there, circles, spheres. Let's just go ahead and insert, strings into the stack, or numbers so that we can add them up. I don't know. Strings are good, they're very easy to see. So I've made a new project called Lecture P. What are we going to do? Let's just go ahead and import java.util.asterisk so we get absolutely everything in case we want a scanner and all that. We know that we want the array list, which is in there. I need to bump the size of that up. Got a new computer. Maybe JavaDoc will actually work on this one. Yeah, hopefully a little bit more visible. Okay, so we're going to make a new class. Can't be a public class. I wonder if it could be a public class if I defined a class inside a class, which you can do. You can even define a class inside of a method. It would only be available in that method, just like a local variable is only available in, in that method. But all right, class my stack, and it needs an array list in there, which I'm going to give the ingenious name of L. It's going to be an array list of strings. There we go. I can't think of a reason to give a constructor unless the constructor was going to actually generate the array list, right? If we were going to make a nice, good class, data private, methods public, whoops, slipped into C++ there, no colon there. All right, and we're going to add two methods, push and pop. The way a stack works is, imagine a stack of dishes that was, I don't know, on a rubber desk or something. This is kind of silly. But anytime you wanted to put something on it, you would push it on the stack, and the stack would, all move down to make room for the top item. And then when you wanted to take something off the stack, you would pop it, and you would get that top element off of it. So that means that a stack is last in, first out, or first in, last out. They mean the same thing, right? Because just like if you're putting pieces of paper on a stack, the last piece of paper you put on it is the first piece of paper you're going to take off of it. So we could just add that as a comment somewhere. Stacks are LIFO, last in, first out. The two operations we're going to support are push and pop. Maybe we'll implement a size to, return the number of elements in it, right? We could do isEmpty, but you can always just check to see if time is equal to size is equal to 0. What else? A clear method, right? Wipe out the stack completely. So let's make some methods. Public void push, and it's going to take a string as a parameter of what to push on it. And we need a pop. It's going to return a string. Kind of like a getter and a setter, right? For now, we're just going to return null. We'll go ahead and fill this in a minute. We have a problem though. If they popped more items than that are actually on the stack, it's going to generate an exception. We need to cover exception handling real soon. Hopefully you had a taste of it in your first Java course. And then let's get the size. Public int size. For now, we're going to just return 0. And then public void clear. And all it does for now is just need to return. Or it doesn't need to do anything, right? Because returning nothing is the same thing as doing it right. Okay, so what's push going to do? Why don't we do everything into the beginning of the list? Right, we can push by inserting into the beginning of the list, and we can pop by retrieving the element at the beginning of the list using .get. Okay, so here we go. L.add into position 0. And we could use append, right? But then when we do a pop, we'd have to locate, the last position of it before we popped it, and that wouldn't be a bad idea. I'm considering that. Yeah, nothing wrong with doing that. Okay, so we're going to add our string. Add to end of list. That's what push does. What does pop do? Gets and removes the item at the end of the list. Now to do that, you have to know the length of the list. Int x. We could get all fancy and call it last index, right? I'm just going to call it x. Is equal to L dot size, parentheses in parentheses, and we're going to get L minus 1, because just like an array, you can access elements 0 through n minus 1, where n is the length of the list. Yeah, since I'm talking about n, I'm going to change x to n. So string s for what we're going to return. Excuse my voice. Equals L dot get variable n, right? Get it at that position. Get last element in list. Now we need to remove that element. So L dot remove n. It offered to remove element s. It would search that list and remove the first example of that string. But we might have inserted that string several times, and we're adding and removing from the end of the string, so it would not necessarily get to the end of the string. So instead, we're going to remove. Well, there we go, right? But we should be checking to make sure that size is not equal to 0. And if size is equal to 0, we need to return something. What are we going to return? Empty string or null? How about null? We could throw an exception, which is what get would do if we asked for an element number that did not exist, right? Or you tried to pop too many times on a stack or something like that. But let's just return null. If parentheses n equals 0 in parentheses return null. We really should rename n to a better variable. All right, and then string s is equal to L dot get subscript n, L dot remove subscript n minus 1. If the size of the list is 1, we're going to get element 0. Whoops, that should have been a minus 1 as well. I'm being sloppy. That's the last element in the list, and now we're going to delete the last element in the list. I guess we could say remove. We're kind of duplicating our code a little bit when we do that. If your comments match the code too closely, it's kind of silly, right? But anyways, remove last element in list, and then return s. Did remove actually return the element that was being removed? Why am I asking that? Because this may be an unnecessary step if we could do this in one fell swoop. Let me see. L dot remove parentheses. How about I just viewed a Java doc? That wasn't working previously. Maybe it's going to work now. Ah, for Pete's sake. I must have to install that. L.remove. No, L.remove just returns true or false based on whether it found it or not. There's really no chance of it not finding that element. Okay. So we can go down to main and test this out. But lastly, size needs to be able to return the size of the array list. So instead of return 0, return L.size, parentheses, in parentheses, semicolon. Okay, that's our fake stack. What do I mean by fake? Java gives us a stack class, but I want us to implement our own. Just to kind of reinforce an idea, how to use the stack class. We've seen how to allocate it. We've seen how to add items to a stack. We've seen how to get items from a stack, get the size of them, how to remove items from the stack, remove by index. All right, I think they're pretty good. Now lastly, .clear, L.clear, wipes the stack out. All right, let's go down to main and play with this. Guess we could put a comment. What are we doing here? Right. Remove every element in the stack. All right, so down here in main, we're going to make our stack. My stack st, short for stack, equals new my stack. It would be really cool if we were awesome and could put things like string there or double there or whatever. We need to veer off and learn about templates. But for now, there we go. Now let's add a few items to it. S.push, parentheses, the word 1. And we're going to do the same thing. We're going to push the words 2 and 3 onto it. st.push, parentheses, quote, 2, in parentheses, or in quote in parentheses. st.push, parentheses, quote, 3, in parentheses. Now, we need some way of printing the contents of our stack. And we really don't want to just pop the entire stack just to print them. But even though we're only supposed to be accessing the stack, from one side of it, a stack is also a list. And so we can access the elements numerically as we just, So let's add a method called display. Public void display. Is it going to return a string that contains all of our elements? ToString. That'd be kind of neat. So let's create an empty string and then add elements to it. So for parentheses int I equals 0, I is less than L dot size, in parentheses, semicolon, I plus plus, we're going to be using, we could just use for each. For each is even easier to use than that, right? So delete all that. For parentheses, string v for value, colon L, s plus equals value, plus maybe a tab, at least a space. Quote, space, end quote, semicolon. And then return s. Why don't we put something useful in here that we can see what we're printing out? Stack contents, right? Like that. All right, now we have our ToString, so we can go and we can print the stack after we have pushed some elements on it. So st dot, well, system dot out dot println parentheses st in parentheses semicolon. Or if you like seeing the words .toString there, you could add that, right? .toString, but it's not necessary. Well, let's run it. Let's make sure it says 1, 2, 3 on it. All right. As expected, after we push 3 elements on it, 1, 2, 3. Let's pop an element off. Right? String e for element or whatever equals st.pop parentheses in parentheses, and let's print that out. System.out.println popped space in quote plus e in parentheses semicolon, and let's print the list again. System.out.println parentheses after popping, comma, and after the end quote plus st.toString, or just st in parentheses. Run it, check our output. Here we go, right? Those were the contents. We pushed 1, we pushed 2, we pushed 3. That was the last element on it. So when we popped, we got the last element, and now we only have 1 and 2. Let's push a few more things onto it. st.push parentheses quote 4 in quote in parentheses semicolon st.push quote 5 end quote in parentheses semicolon. Now let's pop 2 things. E equals st dot, or just pop 1, right? And let's print out the list one more time. System.out.println parentheses after pushing and popping, comma, space, end quote, plus st in parentheses semicolon. All right, so after we popped the 3 off, only the other 2 elements, the first 2 that we pushed on, were there. And then we tacked on 2 more elements, right? 4 and 5, although we never see reference to 5, it's there. And then we popped it off, so what did we pop off? 5, leaving 4. All right, so we have implemented a stack. Q's a little bit different. Q uses traditionally 2 methods called NQ and DQ. What is a queue? A queue is like a line. Line of people, I mean, that's the definition of queue. Is, you know, in Britain, they don't say that people are standing in lines. Some people say that they will stand on line, but other people will say that they're standing in queue. So the first person to get into the line is the first person to get out, as opposed to a stack where the last thing that's pushed onto it is the first thing that gets popped, right? So just like a printer queue, right? The first document you send to the printer is the first document it's actually going to print. If a printer queue was implemented as a stack, it would be really annoying, because then the last person to print something, you submitted your, you know, your doctoral thesis, but somebody else came along and printed 2 jobs. After that, it would print those first, if it was a stack, but it's a queue, so it's going to print them in order. So that's what a queue is. So we could call our elements NQ and DQ. But I believe that in Java's particular implementation, they just call it add and remove. Yeah. And so you add something, it adds it, you know, to the end of the queue, and then when you remove something, it removes it from the beginning of it, instead of from the end, like the stack. Let me make sure that there's no NQ and DQ methods in Java. All right, DQ, double-ended Q, NQ, just checking something out. So the way a queue works, you insert things into the rear, and when you take them out, you remove them from the front. Could have implemented it vice versa, just like the stack could have been implemented differently. We could have been inserting and removing items from the front rather than from the end, like we did. Alrighty, so just as I was thinking, the queue implemented like this. If you want to insert items into it, you call it add. When you want to remove items from it, you call remove. So we could change our stack class here to be a queue. In fact, that's going to be a homework assignment based on this. Modify the myStack class from our lecture to be a myQueue class instead, implementing queue features. So you're going to want to change the name or remove or whatever. So there will be no push and pop methods. Instead, you will have an add and a remove method. What should add do? It should append it to the end of the list. What should remove do? It should return and get the beginning of the list. I really don't like just calling them add and remove, because that sounds like list behavior, and we wanted to talk specifically about queues, but the developers of the Java API kind of disagreed on that. So one more thing that we should have done to our stack here is actually pop every single in it, every single item. That could be just done with a while loop, right? So while true, in parentheses, we're going to get the item, and if it's not equal to null, or if it is equal to null, we're going to break out of the loop, right? So E equals st.pop parentheses in parentheses. If parentheses E equals null, in parentheses, break out of the loop, the list is empty. Else, let's pop. Well, we already have. We could print the element out, right? So system.out.println parentheses, popping space plus E. Print that element out. All right. Instead of while true, we could do while st.size parentheses in parentheses greater than 0. That'd be a better way to do it, because then we don't have to check to see if it was equal to null. There, I like that better. That's a good way to do it. And while true and checking for null, that was kind of for the birds. We don't want to try to access the stack if it's empty. And so doing a pop on an empty stack, not a good thing, because that sets us up with the idea that that's acceptable, and it really is not. It will generate an exception if you do it on a stack that the Java API gives you. All right, and there we go. Right here were the last contents of our stack. And when it came off, 4, 2, and 1. All right, so there will be no push and pop methods. Instead, you will have an add and remove method. In some implementations of stacks, you will see add referred to as enqueue, just in case you go Googling and you want to learn more about stacks. And remove will be called dequeue. Add needs to append an element to the end of the list. Remove needs to get and remove the element at the beginning of the list, or return null if the list is empty. You can leave the toString, size, and clear methods that are already in the class. But toString should not call it a stack, it should say queue, right? So then what is your main going to do? Your main method should create a myQueue object, add 3 strings to it, or add 5 strings to it, and then display the contents of the loop by calling the toString method, by calling the stacks toString method, just like we did, and then with a while loop, as we also demonstrated. While, not empty. While is size greater than 0 kind of loop. Make sense? Might just take you a few minutes. Really, the only difference is where you're removing the element. Used to be when we did pop, we got the last element of the list, and so we used .size to calculate the value of the index of the element that we were going to return. This time we're just getting element 0. And of course you're going to change all the names appropriately. Right. Everywhere we refer to a stack, you're going to call it a queue instead. Alright, I think that gets you the concept of a stack and a queue well enough. Now yes, the Java API also gives you a stack and a queue. Not sure we're going to cover that, or if this is going to actually just be adequate, because now that you know how to use a list and you have the concepts of a stack, .push, and .pop, you can go out and grab just a little bit of documentation and you would be ready to go if you wanted to use the Java APIs. Okay, so one thing I want to check is which stack class is so-called thread safe. Thread safe means that you could access the same data structure from multiple threads. Not that we've talked about threads, but we're going to. Multiple threads are a way of getting the program to do multiple things at the same time. So, thread safe stack in Java. Java Collections is a legacy implementation for thread safe stack based on Vector, which is a synchronized variant of Arraylist. I'm not sure why it's a legacy. I guess it uses lock for all the operations, which could hurt the performance for a single-threaded execution. Well, what does lock mean? It means that no other code can come in and modify the list while your code has a lock. And when I say your code, the current thread of execution. Let's see if it mentions what the better stack is called. Oh, usually there's a third option besides push and pop, which is just peek, which fetches the element without removing it from the underlying container. We could go ahead and add a peek option to our myStack class. Thread safe using logs, sure, that's fine. Or you can use something called an array Deq, which is a double-ended queue. And a double-ended queue you can access through either end of it, right? It's double-ended. I think we're just going to stick with our current MyStack class and conceptually stick with push and pop. But let's add that peek method. What does peek do? It returns the top element without actually deleting it. So it's going to look a lot like our pop method. So let's go back and copy our .pop, make one called peek, and we're just going to remove the part where we remove anything, right? Pretty much we're just going to comment that line out. Okay. So what did I do? I copied the code. I'm going to change it to peek. I'm going to do everything except remove the last element. We should add some documentation as to what this is doing, right? Add to the end of the list. Well, what is this doing? Add an item to the stack. I'm going to say to the quote top of the stack, which is really the end of the list, which we can see here. And this is going to be remove and return the item at the quote top of the stack. That's what pop does. What does peek do? Returns the item at the top of the stack without removing it. What does size do? It's so obvious, I'm not going to even mention it. Clear, yeah, it removes every element in the stack. I could just cut that comment, push it here. To string, return stack as a string, right? Okay, I think we're good to go. I'm not going to even test the peek method out. It's bad programming, but oh, why not? System.out.println parentheses stack peek returns space end quote plus st dot peek parentheses end parentheses. And so whatever the last thing that was pushed on it that has not been popped, right, the so-called top element in the stack will be the one that we see. Right. And so if these are the contents of our stack, then when we call peek, it's right there. And if we called it 2 times in a row, we would see that it was 4 at each time because it's not actually removing that element, it's just peeking at it. We need to modify our homework instructions just a little bit. Peek does the same thing as remove. Or how about just peek returns without removing the element at the beginning of the list. Or null if the list is empty. All right, I think that's good enough. All right, if we went and looked at the PowerPoint for this, we would see that there's additional information about queues, about stacks, about using the Java API. Actually, I'm not sure that they cover stacks. We'd have to take a peek. And there might be additional information. Go take a peek at the PowerPoint. I thought I'd already downloaded it. I'm sure I'd already downloaded it. Oh, why don't I just use the preview built in? Where's our PowerPoints? Way down here. Chapter 10, collections. There we go. And all right, the linked list class. The linked list, well, we can go and take a peek at it real fast. So a linked list is like an array list. But instead of using an underlying array to store the data, it uses a chain of references. And it's a classic programming problem about how to implement your own linked list. So that as you add items to it, you can insert in the middle of it and make space for it. Well, sounds like the array list to me. So array list and linked list implement many of the same methods: get, set, add, remove, clear, and size. That's because they both implement the same list interface. We'll be talking about what an interface is very, very soon. So you declare it just like an array list. I'm not seeing a good reason to choose to use a linked list rather than an array list. With a linked list, it's easiest to find, add, or remove elements that are near one of the two ends. However, finding an indexed element is much slower in a linked list than an array list. Kind of sounds like a problem to me. Measuring method execution time. Now this would be a good thing to do, but we're going to go with that in another lecture. And then a queue. A queue is a first in, first out waiting line, whereas a stack is a last in, first out, LIFO. A queue is a first in, first out for the reasons that we've already talked about. You could implement a queue using linked list or an array list. It notes that array Deq, D-E-Q-E, is the most efficient way. And it uses .remove and .add, just like the class that we were implementing in our homework. And then a stack. All right. I don't see anything in here except for using time functions to measure the performance of code that we need to cover in here. Yes, I do. Really important. Maps. Dictionaries, as they are known in Python. Okay, so we have more to cover in this chapter, and that'll be the next lecture.